Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we are going to get back to our training with classic mechanics today. Hopefully you guys are having a really good week so far. It's Tuesday, so you're almost there to Wednesday, almost to the middle of the week, so congratulate yourselves for basically making it this far, whether you be in your studies or whether you're just trying to get through the week or you're just working your way through the week. So we're almost there, we're almost to the halfway stretch, so give yourselves a pat on the back. Oops, I don't want to start the study timer before we actually start studying. Anyway, so last time we were here, we had done, I think we did like we completed 5 problems, I believe. Let me take a look here. So we got up to 7.6. So 1.6, I mean, not 7.6, 1.6. So, let us see, because we did problem 5. Now, I haven't checked these problems. Now, this is problem 1.3. We still haven't finished that one. Forgot to box this one. Hey, Nstunky. Happy Tuesday. And if you guys are not familiar with Nstunky's work, Nstunky also streams some awesome math content as well. So I'll give you a shout out, Nstunky. There we go. But what's the best part of your day so far, Nstunky? So we were on I think today we should because we're on problem 1.7, but we're also on problem 1.3. So I had an idea after stream, like with 1.3, so I think for now we're gonna go back to 1.3. I'm not gonna go back up and reroute everything I wrote, so we'll just leave 1.7 alone for now. So we'll go back to 1.3. Let's see. So the question in 1.3, I don't know if you guys can see it. Let me know if you guys can't see like what's on the pages. So it basically says, by applying the Pythagoras' theorem, the usual two-dimensional version twice over, prove that the length of R of a three-dimensional vector R satisfies R squared equals x squared plus y squared plus z squared. It's visible? Okay, cool. So my idea for this was to change everything in polar coordinates, so let's drag this over here so it's better to see. And then if we think about the cross product, oops. Best part tricky. The best part are coming for sure, but so far. Well, I mean, you got up this morning, so that's one. To get my butt out of bed in time for 8 o'clock talk about discrete curvature, which was a good time. Nice. See, there's at least something. I know there's at least something that would count as a good day for you. Oops, I almost forgot the study timer. Just disengage my model here. Hey, good morning, Penn Center. What's the best part of your day so far, my friend? And also, I will give you a shout out as well. If you guys are not familiar with Penn Center, an awesome math streamer, does real analysis as well as linear algebra. So if you want to learn those, be sure to check out Penn Center's lecture streams, or math streams, I should say, because lecture makes it seem like it's boring when it's not. I'm wrangling with how to teach diagonalization for a bit. Oh, okay. That sounds fun. learning how to like actually teach yourself something is usually a good exercise to basically see if it will be good to teach people that. Just got back from watching data science presentations, so it was a fun morning. Nice. I'm doing okay. I'm doing all right. I can't complain. I'm on stream right now with you guys. Now, we have a perplexing problem. Now, the thing I like about this problem is that once I was able to put it down yesterday, I was like thinking in my head like how to actually try to solve it. I mean, that happens to me like a couple times, but at the same time, it's like those problems you feel as if like, even though it seems complex, you feel as if there's like stuff that you know in order to make the problem more manageable. Although I don't know if it's the right procedure to go about it, but I'm just basically just pulling stuff out of a hat here. Maybe I should have evaluated it before we factored out the... wait, I'm sorry, I was, is that a question to me? Super distracted. No, it's okay. It's okay. I actually forgot what I asked. And I don't think I don't, like, I basically said, like, you know, like, try to figure out a way how to teach, like, yourself, like, a subject that you're probably familiar with, is, like, probably just as helpful as, like, better understanding the material. I think that's what I said, but I don't know if I asked a question, so... MSB, I'm very confused by this calculation. Yeah, so basically, for problem number 1.3, it basically says, by applying Pythagoras' theorem, the usual two-dimensional version, twice over. I don't know what they mean by twice over. It says, prove that the length of R of the three-dimensional vector R satisfies, I'm guessing it's basically R squared equals X squared plus Y squared plus Z squared. So I'm guessing they probably say, like, prove these using, prove the distance formula for this. Like, why does that satisfy the distance formula, I'm guessing. And right now, like, I think for two dimensions it's easier. I mean, yeah, like, for two coordinates it's easier with X and Y, because you can basically do, like, you know, put it into polar coordinates and then basically turn it to R squared, like R squared, and you factor out R squared, and then basically you get cosine squared plus sine squared, which is 1. But for 3 dimensions, I'm actually trying to figure out how to do that for 3 dimensions. Yeah, for 2 dimensions, it's the Pythagorean theorem, right? But for 3 dimensions, I'm actually trying to make sure that R squared equals R squared. So that way it's like a proper, I guess, like, distance formulation to get the length of R. I mean, that's my original idea, but if I'm going at it the wrong direction, you guys can tell me. I'm pretty sure this is just a cakewalk for you guys. It's like, this is simple. I already know what to do. Because we have this little... Because the reason why I got this part was that I was thinking of Z being the cross product of X and Y. And then I just convert that to polar coordinates. Can you draw a picture of the situation? I didn't think about doing that, but it could be a good idea to do it, I guess. No, actually, what am I doing? We can use lines. So we can do this. I guess we'll just draw a random vector. So let's just say we draw a vector right here, and we'll call this R. I mean, that looks pretty nice. Oops. Didn't draw that dotted line very well. We'll just put it like that. Maybe drawing a picture will help, but because like I guess this is like where I know the formula, but I just don't understand where it comes from. Yeah, this problem has been like flustering me a bit. I'll be right back, guys. Just give me 1 second. Okay, I'm back, guys. Sorry about that. Okay, is that theta the same as that alpha? Oh, I wrote an alpha by accident. I probably should have just wrote theta. I've been reading too many books that use different angles. Yeah, we'll put theta. We'll put theta. The thing is that we can reduce this. Thing is that this side I have to find a way to minimize it. So that way we can because I want to know why is it that this formula satisfies R. I don't know if this counts as sort of like a mathematical proof or anything. I mean, if I remove this, forgot that part. Oops. Should be to the 4th power. I mean, we could also factor out the cosine and sine, but I mean, I haven't tried that yet. Hey Mavor, what's the best part of your day so far, my friend? I'm trying to solve 1.3. Maybe I'll move on to the problem 7. Because this problem is like kind of... Oh, did we reach the bottom already? Oh, there is no bottom. Okay. I was about to say it's supposed to be an infinite scroll down. See right here. Problem 7. Prove that the two definitions of scalar product are r dot s as... Okay. Yeah, I remember this one. So it's like... So we have to prove that this is equal to this. In addition... are equal. One way to do this is to choose your x along the direction of r. Strictly speaking, you should first make sure that the definition is independent of the choice of axis. axes. If you like to worry, if you like to worry about such niceties, see problem 1.16. Because I think there's a way to actually get this with like the laws of cosines. I think that's the reason why the length of S and the length of Y, I mean the length of R and S are like part of cosine. So, because if I remember, the laws of cosines are A equals, let's see, I think minus 2 Oops, that doesn't look like a good gamma at all. It's interesting. I remember last week there was a viewer asking if we're proving this formula or just using it. Yeah. Because I think we have to. Yeah, it says prove the two definitions of the scalar product. So... yeah, we're doing Taylor, Tyrion. What's the best part of your day so far, Tyrion? Yeah, because I know this property comes from here. The thing of it is that I have to figure out how to start. I think that's like basically the premise behind like every superhero journey. It's like they want to change the world, but they don't know how to start. Because the dot product is basically a scalar, so it's just a number. Hey, bamboo fishes. It's good to see you again, too. What's the best part of your day so far, bamboo fishes? I'm full of regrets, so the best part of my day could be having less regrets. Okay, that's something. Because I'm guessing that R would be here, and then length of S is here, and then times 2 for these two, and then we'll just put theta. Now the thing is that for what it equals to, that's supposed to be the actual dot product between these two. But then that's also squared here, in this case. Best part of my day so far was having no issues. I mean, that is something. That is something, yeah. I mean, I know how I would feel if I didn't have that going on for me. It would be very annoying. And it proves that your body's healthy, so yeah. I don't deny you there. I wasn't expecting that, but then again, like, that's what keeps chat, like, lively. The randomness sometimes. Because I don't want to use the definition of what the dot product is, like what I know of it. Because the thing of it is that we have to make the dot product equal to RS cosine theta. So I feel like there's something I feel like I can see something, but I just don't know what it is. Oh, I always forget the chat sometimes blocks, so I gotta remember to remove stuff. We'll just call the scalar t. T will be the what this equals to make it easy to see in the eyes. Okay. To find this type of question in a physics book, I'm like, dang. How do we get started with this? Right, yeah. You are right. You are right, yeah. Missing here. Because I know T is supposed to represent the dot product, but at the same time it's like... Well, I think the thing we can do is take the square root. But I don't think that will do much. No, I don't think that's gonna do anything. Yeah, it's usually these type of questions that I get very stumped in. Because I'm like... I can apply the formula, but I just don't know where the formula comes from. But then again, that's probably like how applied mathematicians think. It's like, how do I visualize those? But then again, this is also could be like a little bit of math proofs too. The struggle of solving a problem. Because I know I have to get t to basically take out this, and this 2 here. And I think I've seen it before, but I just don't know what the methodology is. I think that's the reason why I skipped those 2 problems. Well, we ran out of time for like last session with not session, the last stream with 1.7. With number 3, I was also kind of confused because I was like, there's got to be a way to actually get the distance. Or maybe I'm doing the question wrong for number 3. I already spent like a couple minutes on this. You know what that means? If it's already past like 20 or 10 minutes, it's time to skip. So we'll skip that one for now. Let's see what 8 does. What is question 8? Okay, use the definition at 7.1.7. Oh, it's a follow-up question. So that means we can't do it yet. 1.9. In elementary trigonometry. Let me just... Oops. Where's my mouse? There it is. Oops. Didn't mean to do that. There we go. Let's see. What does 1.9 say? In elementary trigonometry, you probably learned... Oh, you guys typed stuff. I didn't see that. R squared is R dot R or... Oh, okay. So your approach in 3 is definitely wrong. Okay. This one? Probably it is. Usually sometimes when I think I'm being clever, it probably is absolutely 100% wrong. Yeah, maybe I'm not reading the question right. Because let's see, number 3 says, by applying the Pythagoras' theorem, the usual 2-dimensional version twice over, prove that the length r of the 3-dimensional vector r satisfies r squared equals x squared plus y squared. Do you need the angle for 1.3? Not really. The only thing I can think of, because the thing of it is that I thought like the point of the problem was to prove that r squared equals r squared. So the thing of it is that I thought I would be clever and just try to put polar coordinates instead of just using xy coordinates. I mean, that was my original idea, but I don't know if that's what it means to solve the problem. Because it says, prove the length of r satisfies r squared equals whatever we have here. That's what I thought the 1.3 is. So, where were we? Oh yeah, we were on, we were trying out, 1.9. They just want you to write r squared rho squared plus, where rho squared equals they just want you to write this rho squared, where rho squared is equal to x squared. Okay, so what you're saying, Mavort, no, that's not what I want. Where is the pen? So we'll just erase this. Actually, do this. Oops. Take that. Backspace. So what you're saying, Mavort, is that we have to, so r squared equals x, y, z. Where rho squared is equal to y. But why? How did you get that from that problem, though, Mavort? Twice over. Is it because, like, basically they just want you to, like, make it look like it's doing the Pythagorean theorem twice? Is that how you got the, like, I guess that conclusion for this problem? Okay, so, alright, so what you said before, Tyrion, was that this is equal to this. So then S would be equal to all right. So expand the arse. Expand the r squared. So then r squared equal to r squared is c in the laws of cosines. So I'm guessing you have to do FOIL with this. Oops. Just gotta scroll back up on chat to see what Tyrion typed, just so that I can follow through. Is equal to is C in the cosine, so go back to look at what you call C. So we call C squared equals, oops, squared. So then basically, so this side should be, if I understand it, S squared minus 2r cosine theta. And I'm guessing we cross out a lot of this stuff. So drag this down here. This goes bye, this goes bye, this goes bye, and then we're left with cosine equals negative 2. And then we just divide by 2 on both sides, giving us okay, so where was I getting stuck with this? I think I was getting stuck with like how to classify this product. So C minus S squared. So let's see, if R dot R is R squared, and if this is S squared, then now I gotta figure out where this comes from. So that means because this would turn into minus 2R plus what's these? So these two basically will. Things you were missing was C, the difference of your S and R and S is noting C is equal to R minus S, and expanding that on the I knew the cosine was the law of cosines was involved. The thing of it is that I wasn't sure how to write the scalar that we're supposed to equate to. But thank you, Tyrion. That actually makes a lot more sense. Now the thing of it is that I guess I'm just trying to visualize this part, because the thing of it is that you said this and this, so I'm like, okay, I'm missing like what makes this. So that's what I'm trying to like understand in my head. We'll do it in 3 dimensions. Let's say we have vector R, just pointing this way. And we're supposed to have vector S, right? So vectors S and R. Okay, so we'll just make S like, just put S in this direction. You will see the difference. C is in different. Do it in 2 dimensions. You'll need for 3 dimensions. So I think we can just take away click this. Delete that then. Oh, break time. No need, sorry. No need for 3 dimensions. Oh, okay. Alright, it's break time, guys. What do you guys have been up to with your own pursuits? But thank you guys for like putting out like help during those like 2 problems. Yeah. I'm still not I'm still trying to figure out the R minus S squared part. But I really appreciate it. That made it a lot much easier, actually. Sometimes when you guys are telling me the answer, like, well, how to get to the answer, like, I feel like I'm cheating. But at the same time, like, I guess I'm just trying to understand your thought process. Connect the tip of R and S. Oh, okay. So... let's see if we can do a trick here. Can we... we can do it. That's fun. I like that. Yeah. And we'll take the S. That's pretty cute. I like that. I can move the little vector. It's not connected, but that's fun. I actually like that. Let's see. Connect the tip of R to the tip of. Oh, to the tip of S. Okay. So. Just move you here. In the book Linear Algebra Done Right, there is the same exercise, but they give you a hint. Draw a triangle formed by R, S, and R minus S. Then use the law of cosines. I see. Draw S with the common origin. With the common origin. Don't move them, just connect the tip of R to the tip of S. Make a triangle basically, R one side and the other side S on the third side. Oh, okay. That's what I was thinking you guys were talking about. And I'm guessing you get the laws of cosines because it's because the law of cosine and sine are usually triangles that are not like perfect, not right triangles, correct? Because I remember that part with the laws of sines and cosines. Now the one thing about like 7 is correct. The laws of cosine and the law of cosine is generalization of the Pythagorean theorem for triangles without a 90-degree angle. Oh, okay. Well, at least I know that much. I remember solving problems involving those. Those were pretty fun, actually. Actually, like, I'm curious, guys, since we're on break, like, since you guys are like so like, I guess like higher than me in mathematics, uh, like what brought you guys to actually like, I guess like watching my streams actually, because I'm not doing any problems that seems like they're kind of like, I guess like extremely interesting or like unsolved problems. Like, what is the appeal of you guys basically like just like watching me solve math problems, if you don't mind me asking? Because I think like based on like the amount of people that we have in chat, like I always feel as if you guys like are like way past like the level that I'm at, and I'm just solving like these basic problems that probably are secondhand knowledge to you guys. Like what is the appeal of my streams? That's basically what I'm asking. Because some of you guys are grad students and you're basically like studying stuff that is like way above my level, and I'm like, surely there must be like something more exciting like that you guys are researching. I mean, I listen to a lot of math streamers. I like to support the community. But for you specifically, I'm guessing you're just typing that with a thought, and Stunky. I mean, that's true, yeah. Like, math streamers like to watch other math streamers. Because usually when I watch other math streamers, it seems like they are capable of teaching math to, like, a certain degree. Which is exciting. I mean, at least for us. Because like last stream, like one of you guys, I think it was Bamboo Fishes, asked like, do I want to make this channel bigger? And I'm like, yeah, I would like to, because I would like to connect with people that love math and physics, because I don't really have like people in real life that I can share this interest with. Although I'm not like a teacher, so I feel as if like the material I go over is like really extremely basic. You got a good voice and vibe. Explain yourself well. Oh, thank you. I really appreciate that. I'm sort of kind of know physics, so I'm sure you'll get things that are new to me. Yeah, like the thing of it is that there's this other book I'm reading. It doesn't have problems in it, but I really like it because it's meant for like the layman's learner. Let me see if I can. I think I have a PDF version of it. Actually, I should just go right here. I know where it is. No, not this one. That's the problem with like my math and physics. My math and physics file. It has like too many things in it. Here it is. Here we go. Oop. Can I bring this down, please? I want to drag it down. So this book. Where? I want to get to the cover. So this book is like Lagrangian mechanics for non-physicists. Like, I actually have the physical version of this book, and I started reading it like a while ago. It doesn't have problems in it, but it does explain like a lot of the math behind like dang, I'm getting tongue-tied. The math that's involved with classic mechanics for like, I think, a level for people that want to get into theoretical physics. And what I like about this book is that it goes all the way up from not only Lagrangian mechanics, but it goes all the way up to Noether's theorem, which is right here. Noether's theorem. I actually I skip around this book a lot because sometimes I'm like, okay, what do I need to know, and like, what is something interesting that I can read? Now, of course, I don't know anything about Lagrangian mechanics or the calculus of variations, so, but I like the way this book introduces them. Of course, there are some typos in it, but at the same time, it's like, pretty exciting stuff. I posted in general. Alright, let's take a look at what... Okay. Ah, I see. Oh, you wanted it drawn that way. Okay. Yeah, when you said common origin, I was like, didn't I do that already? But I get what you're saying. I get what you're saying. Now I get it. Yeah. Okay. So... -2 to the cosine was a... Oh, okay. Okay. So like the vector is equal to, right? Yeah, that's what I was trying to simplify in my head. I guess with the step here, I was seeing this step, but I wasn't seeing how we got to here. But I think like basically when I saw it, I was seeing pieces, so I was seeing this, but I was seeing this, but I wasn't seeing this middle part here. Like I knew it had to be like something around here, but I didn't see it because of these things. But thank you for putting that up, Tyrion. Appreciate that. Yeah, like I know I have a lot of gaps in my my recollection. So plays a role in the C for the... Okay. So I'll keep that in mind for like few, because I know like some physics books they do introduce the law of cosines in it. I don't know if they use the law of sine a lot. I have seen like a problem where it involved the law of cosine though. I mean, do physics problems use the law of sine? I have seen when they use... I've seen physics problems where they do use the law of cosine a lot. Not a lot, but like I think I've seen one problem that involves that. Yeah, but like I said before, this book I think is really, really interesting because it introduces, I guess, like Lagrangian mechanics for like, because I think like classic mechanics, if I'm wrong, classic mechanics, they basically introduce you to Lagrangian mechanics and mainly how to use that with physics problems, correct? Is that like the whole, well, not only Lagrangian mechanics, but also the Hamiltonian. Is that correct? Like for people that have taken physics, is that the main bulk of classic mechanics? Or am I wrong? Okay, I'll just disengage the timer there. The action principle produces the Lagrangian. Right. During my entire study, I have never used the law of sine even once. I only remember it from school. Oh, okay. Okay. Yeah, because I think like with cosine, with the law of cosine, it's a little bit more applicable because you can think of it as like calculating distances. Whilst the law of sine, it seems like there's like just an intricate how should I say, an intricate like symmetry. I don't know if it should be symmetry or like some sort of intricate internal I guess it is symmetry, like symmetry between the angles and the sides. Let's see. I can't find it on actually I actually had to like pay for this. I actually have to pay for this PDF. Cause like the person that wrote this book, they made a course and they made a course on like general relativity and maths. Like I haven't actually gone to their site in a while. I actually purchased this, so that's the reason why I have this. That's probably the reason why it's not on Anna's archive. You can buy this on Amazon, actually. The price for this book is actually very reasonable. But the action principle is also used in... Yeah, because I also have another book. Let me see. It's in my same file here. It's called Field Theory for Non-Physicists. So this book, they do talk about, I think it's called the Lagrangian, was it the Lagrangian? It's not just the Lagrangian, I think it's called the Lagrangian parameter. Let me see, where does it say? The Lagrangian density. Lagrangian and Hamiltonian mechanics are very interesting because they're so elegant. It also turns out that they have applications outside of mechanics. For example, reinforcement learning, robotics. Oh, okay, that's interesting. So what you designate as your Lagrangian, whether a classical or quantum Lagrangian, describes the system. Another way to do those things is using the Hamiltonian. Right. Because, I mean, obviously you have to learn classic mechanics in order to do quantum mechanics. Because I think, does this book cover the Hamiltonian? I think it does. Let me see. I mean, it's mostly for Lagrangian, but I think they do introduce the Hamiltonian in here a bit. Let me see. I know they cover it once. Where is it in the context? Because we got Lagrangian. Because they do go into Noether's theorem, which is like, I think they do introduce a little bit of Hamiltonian a bit. But I don't see it. It's probably like a small section. Either a small section or just a minimized, like, probably like in like a little, like, square. Quantum mechanics is mostly functional analysis. Oh, really? Interesting. I did not know that. You should know classical because quantum mechanics will borrow from classical. Yeah, that's what I figured. Because you actually have to know the actions of, like, the things that happen physically, like, in front of you, instead of along with the things that are happening in the small scales. Alright, before we get into the next session, guys, I'm just going to use the restroom, so I will be right back. So, BRB. Alright guys, I'm back. Sorry to keep you guys waiting. So we did solve how to get the cosine. We did solve how to get the cosine part of the dot product, but I think what we didn't do was how did we get the dot product is equal to the summation of R and S, the component version. That's the one thing we didn't do yet, because I think it wants us to do both. Yeah, prove the two definitions of the scalar product as and the summation version. So we did the cosine version. Now we gotta do the summation version. Like, how would you prove that? Anyways, Lagrangian and Hamiltonian mechanics are often terribly explained in physics books. So if you found a modern textbook that is only focused on that, that's great. Yeah. And I think like you learn the most when it's not targeted towards like, I guess, people that are like doing undergrad, or like people that are not supposed to be, I guess, like literate in the material. So use the definition just to prove the line cosine to show the summation. Do you mean the law of cosines, Tyrion? Because you said line of cosines. Use the definition you just proved to... i.e. I'd... 190. Okay. So the basis vector I, or the J or the K. Because technically, when you think about it, it's like R. Oops, I forgot something. Forgot these little bits. And we'll just say that data is equal to 90. So therefore we are left with see, R is okay. Yeah, that might be a little bit easier. Forgot the little hat. Okay. And then we got... Okay, so we now know that. Okay, just use the fact that R dot... Okay. So I'm guessing just multiply them in some way or another. So R times write it like that. That's That's for R. Actually, I should move this. Make it a little bit easier. Where's that? Put it like here. Okay, you guys can see that. That is. And we're assuming that basically it's 90 degrees for cosine, so then we have to multiply all these together. Oh yeah, and the hats will cancel because they're dots. Right, yeah. Wait. Is it safe to assume that? I mean, I know it like logically, like basically based on my experience with like the dot products, because they're 90 degrees. Yeah, I think that's a fair assumption. Yeah, just use the dot product. It's not assumption, are perpendicular to each other, right? Yeah. So yeah, okay. So now I see where it comes from. Okay. Yeah, now I see, because basically those factors go away when they like basically come together, because perpendiculars always result to 0 at that point. With a magnitude of 1, yeah. And when you do the dot product, they basically the components will multiply by 0 if it's not there. What did I say it was 0 by accident? I'm pretty sure I said 90 degrees is equal to 1. Well, if I did say by 0 by accident, that's my bad. Yeah, I meant cosine 90 degrees is 1. Okay, so now I understand where it comes from. It's basically when cosine is 90 degrees. Okay, thank you for that, Tyrion. Right, that's what I was explaining before. Like that's what I was thinking about, the middle components of the units of the unit vectors. Oh, whoops! Forgot to put the timer on. Okay, so we managed to understand that problem in a much deeper level, so I think we can move on. So, okay, use the definition from, let's see. I think now we can do 8 because thanks to your guys' help, we managed to figure out what 1.7 is. Unless, actually, because I actually have questions on this one, 3.1. I'll scroll back up to it. So, because the one thing that, because I know Mavor basically said, oh, it's just basically putting rho in place of x plus y. So I'm guessing basically you're kind of reducing x and y to just one parameter, or one, I guess like one component. Is that what they mean by basically doing the Pythagorean theorem twice over? Okay, gym time before it gets too crowded. No problem, Tyrion. Hopefully, you'll burn up a good sweat at the gym. Yes, that's why that being. Oh, okay, okay, okay. Yeah, because they said twice over and I didn't get what it meant. I didn't realize it was that simple, actually. Knock on wood. Knock on wood. But thank you before that. Because like, the thing of it is that I thought they wanted to do. I thought they wanted you to do it in some crazy like mathematical proof type of method. Usually when it comes to those type of questions in physics, I get a little bit tongue-tied because I'm like, oh my gosh, what am I missing here? Okay, so we managed to get, I mean, you guys managed to just tell me how to solve the problem. I mean, I am learning, like, a little bit about what you guys are talking about. No, it's actually simple here. Oh, okay. Yeah, because, like, sometimes, like, I just hope that I'm learning through you guys whenever you explain how to solve a problem. Because, like, when you guys tell me, like, how to do certain things, I worry that I'm cheating. Or cheating myself in that way. I mean, hopefully you guys will keep me in check if that happens. Here we go, 1.8. Okay, use the definition to prove the scalar product is distributive. That is plus right is equal to if R and S are vectors that depend on time. Prove that the product rule for differentiation applies to. Oh, ooh, this is more. This is more interesting, actually. So R is distributed, so we can say that we'll just make it U sub X, oops, not X. U J hat. Ew, I don't like that J hat. There we go. I mean, my handwriting is not the best, but at least it looks more presentable. V. And then V. Plus. Then we'll just put R. I mean, if you, like, question for you guys, like, since you guys have been watching my streams for, like, I think, like, a good few weeks now, like, if you guys think I should, like, work on some stuff to improve on certain areas, let me know. Because usually when I study math, I usually do it for the computations. But I don't do it for, I don't really do that much when it comes to, like, I guess, like, proof-based, like, problems. Like, actually proving, like, certain mathematical ideas are valid or equivalent to one another. I think it's okay to look up the solution after one has been trying for a while. As long as you try to understand it, that's good. Oh, okay. Yeah, because for me, I'm like a very stubborn person when it comes to problem solving or like solving like math problems or any problem in general. Like if someone asked me a riddle, I would probably spend like days or even weeks like thinking about it. Like trying not to look at the answer even though the answer guide is literally on the table in front of me. Okay, so it's the dot product of these two vectors together. So if we add those two vectors together, we'll just, I'm not going to rewrite like plus those vectors. I'm just going to put a plus sign like next to them. That way it doesn't like crowd too much. And then the dot product of R, so then it will be times Okay. It's equal to, so this has to be equal to the dot product of u plus I mean, thinking about it, it is kind of self-explanatory, but we can try to solve the other side too to make it much more clear. So if we have r times squared, then y squared. Why am I saying squared? Times. Sometimes sometimes when you do math, you say the wrong math, from your mouth. And then plus with r v. Whoops. V J, then Z R Z V. Then when you add those two together, I think you should focus on the fundamentals like calculus and linear algebra. These are the fields everything else relies upon. So a strong understanding in calculus and linear algebra is most important before diving into other things, such as differential equations. Right. Yeah, I haven't practiced calculus at all. Like, Calc 1 I'm okay with, because I remember things like the product rule and optimization. But I do have to practice integrals. Like, I kind of forgot, trig substitution. And series, like, I have to practice those. Usually for me, I just like if it's something necessary that I have to cover in higher math, like if differential equations ask for like series, I end up like learning it while I'm learning, I guess series involved problems with differential equations. I mean, practically it is equivalent, so yeah, I think that works. I mean, mentally I can see it. Hopefully you guys can see that too, actually. Like, the distribution of, like, the v vector into, the addition of, like, u and v. If not, like, you guys can ask in the chat and I'll just write it down for you guys. And try to explain it as best I see it in my head. Because I think A is done. If R and S are vectors that depend on time, prove that the product rule for differentiation products applies to the dot product. Oh, okay. So we need to prove that this is equivalent to it's the product rule. Okay, so let's see what happens. So we have R dot 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 Z and K. So then that would be times with respect to time. So I mean, technically, if they are involved with time, then it would probably be like something like this. Make it look a little bit nicer. So that's R, and then S would be S times T plus Y T plus, oops, so like that. Then so if we take for this one, it would be equivalent to basically saying times prime I plus, oops, ys prime t plus z of r c s prime of t plus k. When learning advanced stuff like differential equations, Fourier transforms, or machine learning, gaps in the fundamentals just becomes wider and wider. That's why I recommend focus on linear algebra and calculus first. That's fair. I think, like, for me, what I worry about is that I know I have to do the fundamentals. The thing of it is that I feel as if, like, let's say if I do like the basics, like 10 problems, and I see a textbook that's filled with 100 problems, I'm the type of person that feels as if, like, I have to do all those 100 problems just to get through that one section, and I know that's gonna not be the most beneficial when it comes to time. So, like, for me, it's like I usually do it, like, I know the gap is like pretty wide and I would probably have to do a lot of problems, but at the same time, it's like, how many problems is enough? I think that's the thing that I get concerned about, because sometimes I would, like, I know, like, I would probably study something and then either I get bored or I probably just do too much of it and I don't focus on moving on to the next step. Because, like, when I took Calc 2, like, when I went back to school, like, I did take Calc 2, but I just basically, like, passed the test, but I didn't remember that much from it. I didn't remember, like, what I studied because I took a summer class in Calculus 2. I did pass the class with an A, but the thing of it is that I was just so focused on the test that I didn't learn how to intuitively, like, remember things like trig substitution or like series tests. Like, I didn't even get to, because it was a summer course, I didn't even learn Taylor series. So yeah. Not 100 problems, only so much that you can get understanding, then move on. Yeah, because the problem with me is that I don't know when to move on. Like, for me, it's like I already have this back thing in my head. It's like, oh, I don't know enough on trig substitution, or I don't know enough about partial fractions. I don't know enough about series. So for me, it's like, I don't know when exactly I should actually move on, or when I should actually go back to the basics, you know? It's like stuff like that that eats away at my head. When you understand something so well that you can explain it to someone else, then you really understand it. Okay. You're making me want to, like, actually go back to doing calculus. Maybe I should do that next week, huh? Do, like, basic calculus problems. Did I write J here? No, I didn't write J here. I just realized that. Oops. It's supposed to be. Oh, nope. That's not what I wanted to do. Shrink this a bit. Expand this a bit. Okay. So we have to prove that this side is to this side. So if we did take the dot product of this specific vector, then that would mean if you did take the dot product, let's say st plus xt st plus, oops, I wrote too many x's. Oopsie. Go. And then we would have to take the derivative in respect to time to that. So then r of t, and this itself would be a product rule because it's between two functions. So then yeah, it would be plus and then plus s of t, and then plus that, so then r of t times s of t, then plus. I mean, I do like writing like equations like this, do hate it though. When I run out of room. Like, if you guys ever do math problems, do you hate it when you just run out of room on a paper or on a board, and you're like, oh, I need more paper. Okay. Yeah, that looks pretty good. Yeah, it seems like they do work. I mean, like, based on like what I've come to understand. That was actually pretty fun. I actually thought that was pretty interesting. That problem anyway. Okay, so what's problem 1.9? As I told you before, I'm doing leak code problems, sometimes equaling coding puzzles. They are currently 3,478 leak code problems. No way one can do all of them. But after a while, you'll notice that you become faster and more confident in solving them. That's when it's enough. Okay. That's fair, because I think the thing that got me to remember the quadratic formula was doing problems involving projectile motion, as well as like free fall problems. I think like I began to enjoy the quadratic formula because of those problems, because they had like physical applications, and I was able to remember the quadratic formula much better with those. And then I looked up more on the math side of it, and I was like, oh, okay, that's what the quadratic formula was for. Okay, in elementary trigonometry, you probably learned the law of cosine for triangle sides A, B, and C. Right, yeah, we just wrote that there. I'm surprised I actually remember this. Where... Actually, can you guys see the problem? Yeah, let me just scroll up a little bit so you guys can see it. There we go. Let's see. Where was I? Oh yeah, where theta is the angle between sides A and B. Show that the law of cosines is an immediate consequence of the identity. Excuse me, sorry about that, guys. I think you should look at the solution at, like, you mean the actual solution or the one that I wrote? This formula is used again and again, so it is a bit more important than the other exercises. The one on the internet. Oh, okay. Let me see, because I don't know if they have answers. Or at least, like, easily accessible ones. Classical Mechanics by Taylor. Let me type in solutions. Wow. Let's see, problem. Okay, here we go. Let's take a look at it together then. Oh, I found a page that gives the solutions, but thank you, Mavur. Thank you for that. Let's see. Prove the definition. Yeah, that's the same as our question. Consider, right? Yeah. According to the laws of cosines related to the minus, right? Because if it wasn't this, then it'd have a, like, these would probably be like, it would be like, I don't know what I was going with that point. Never mind. Forget what I said. Yes, even better, right? Yeah, right. Oh, actually, I should bookmark this. I'll bookmark this page so we can have it for next time. Okay, so let's see. According to cosine and sine, yeah, it looks so neat. Like, look how neatly they wrote it. I'm like, oh my gosh, this is so neat. I wish I could write this neat. I mean, they typed it out, but at the same time, it's like, look at how the solutions are displayed. It just looks so nice. Mine was like, it felt like, oh man, I was scribbling everywhere. Let's see, cosine theta is equal to... consider that... Oh, that's very fancy. Very, very fancy solution. Yeah, that looks very nice. They proved like both at the same time. That's pretty cool. Well, I mean, they did have to do cosine first, but you know, it's like doing it through cosine. I think that's like really, really pretty. It's a really pretty solution, actually. That was actually a good idea, Mavort. Thank you for suggesting that. Yeah, it looks really pretty. I actually like the way this solution looks. Yeah, it looks very elegant. I'll just bring this back up on my second monitor. Okay, where were we? Oh, yeah. Right. Where's my pen? Oh, here it is. Okay. So, what are we supposed to do? Oh yeah, show the law of cosine is an immediate consequence of the identity. Okay. So we got vector A plus vector B squared. And it's supposed to be equivalent to the magnitude of A and B plus vector A, the dot product of B. Okay. So we'll have vector, oops, no. I should write it differently. So we'll put x plus B, then plus y b. Oh, you guys are not going to be able to see it eventually, so we'll just move it on this side. Z. Okay, yeah, you guys can still see it. Cool. Then J, and that squared. This should be fun. My brain is not like thinking correctly here. This is a whole vector, so if we had like a vector like 1, 1, then no. That make it too simple. So like basically like 1, 2, 3, right? Then basically it would be basically 1, then 4, and then 3. So no, yeah. I had to rethink that for a second because I'm like, wait, is that right? Oops. Oh wait, hold on. No, those are... No, if it's just numbers, then there's like... But there's an operation in between them. Technically, these are just equal to 1. Oh yeah, that's right. We're supposed to use cosine. Forgot about that. You are right, Mavor. You are right. Okay. So we have to equate these vectors. So on the left side, so the dot product on that side be then 2 times x of a times the x of b y well, actually, since we are using the law of cosine, we're supposed to do it this way. Where theta is the angle between, okay. Okay, so okay, next we have to prove that this is equivalent to a vector a plus b squared. Okay. Meaning that we would probably have to get a and b and the 2 here out of the way. So, since they are vectors, you add them together and then you make them squared. I'm just trying to figure out how to write this so we can get to where we want to be. Because I know we have like exponents and all that stuff. Like, I mean, not exponents. I know we have an x component, a y component, and a z component. I just don't want to write it all over again. Like all those like components. but I might have no other choice if that's the matter. But there might be... As I remember, so if A times A is equivalent to that, and B times B is equivalent to this, so for some reason I'm thinking of the triangle inequality. Like when I'm seeing this part, I'm thinking of the triangle inequality for some reason. It probably has nothing to do with the problem, but it just reminded me of it. This is not going to look very pretty. Or it might look like a fun mess, but probably doing the long way, but we'll do it. Actually cross these then. Try to draw it first. We got like a lot of variables in here. I think we can do 2 dimensions, I think that should be okay. So let's say we have vector A, then draw vector B, that to be A is B. Now what we need to do Oh, we already finished the session. But, yeah, I guess, thanks to your guys' help, we managed to get most of the problems that we, did so far. So far, so good. Maybe make the drawing a little bit bigger. Yeah, it's because I also have the book on the side, but we'll probably continue that tomorrow. Thank you for your help, Mavor, and, if Tyrion is actually, like, lurking or anything, I'll basically thank him, too, for his help as well. But thank you for joining me today, guys. It was a lot of fun, basically, engaging with these problems. We will continue on with this, like, tomorrow, so if you guys were in the stream, but you had to leave early, or you just turning in the stream right now, well, first of all, if you like math or physics, or just basically like math or, you know, like a production stream in general, basically, drop me a follow. We're just like one away from 50 followers, so, you know how, like, people that are into math love, like, nice, even numbers, so. Academy of Useless Ideas. Okay, so we can give them a raid. Let me make sure that I'm logged into my math spellbook channel, because I probably left it on. So let me just thank you for letting me know, Penn Center. Okay, so yeah, if you guys were at the beginning of the stream but you had to leave early, or if you guys are now tuning into the stream, first of all, drop me a follow if you like math or physics, or just basically love the production stream, to keep yourself productive doing the things that you love to do. Also, let me just put my YouTube channel there in case you guys want to, like, subscribe to my YouTube channel in case you've missed some parts of today's vlog. And if you're watching this on YouTube, drop me a like, and, you know, if you're new to the channel, drop me a subscribe if you can. because we basically do this 3 times a week. You know, just basically studying at a decent pace. And if you want to join our Discord server to talk math or to just basically just talk about whatever things you feel very enthusiastic about, join our Discord server. So I will raid into the Academy of Useless Knowledge's channel. Useless Ideas, sorry. So let's we'll do the raid message. So you guys can copy and paste that if you like. And we will raid into the Academy of Useless Ideas. There we go. We commence the raid. And also, guys, thank you for joining me today. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys on Academy's channel. So take care, guys. Bye-bye.